I have to work 8 hours.
Oh, where?
Oh,
It's fine. After 4 hours, we don't even do anything. So we just get paid instead of doing
I'm just running 5 hours.
Yeah, I won't get to do that tomorrow. I'm working. Yeah, I wonder if that one works.
We are ready whenever you are.
Yeah, it makes it sound, yeah, I have no idea. It sucks. That's completely fair.
Okay, we can get started. I will start with the week-long IR loop, if you don't mind. This is Weather Watch for April 4th. We've had an interesting week of weather, especially recently. So I'll go over that here with the loop. I'll let this loop a couple times first. Because it's been very active. If you watch from the beginning, you'll see there's been a lot of systems going through, especially the United States, but also the Pacific and the Atlantic here. So all of this has produced storms and hail and wind and tornadoes. And I'll specifically pick out certain times here, but I'll let this loop a couple times here because you can see that. Just there's been essentially perpetual precipitation across the United States. Also to note, as we can still see it's cold in Canada and the poles, but that'll quickly retreat as the sun angle continues to get higher and higher and we get into more spring and summer. Especially early on in this loop, you can see all the cold air as it comes down towards the US and then retreats back towards the poles. Still pretty good snow cover up in Canada, and it gets less and less as the loop goes by here. But if I could first start March 28th at 9 UTC. So this was Friday of spring break. If anyone was in Madison, 28th, yeah. If anyone was in Madison, you're probably woken up. We had a decent line of storms that went through southeastern and southern Wisconsin. A lot of hail was reported with these as well. I know there was piles of hail when I woke up afterwards, after being woken up at like 5 a.m. by these storms, but pretty good storms, and they were very small. And then if you could we just scroll a couple times forward, you'll see they were very quick and moved across the state. And then we had a pretty nice day. We actually set a record daily high for March 28th. This was Friday of spring break. It was 78, and that was the record by 2 degrees. Otherwise, spring break was largely boring and not too interesting in Madison specifically, besides this day where we got early convection, and then it was a nice day. It was pretty nice and sunny and warm. Very windy though. That leads me, we can stay on this. Right in its wake, so we had a lot of warmth come up, especially to the north. There was a nice ice storm that began forming over northern Wisconsin into Michigan. This is the beginning of that ice storm. There were severe thunderstorm warnings for icing and sleet. And so it was probably hard to tell what was hail, what was sleet, but this was the beginning, and it was just a band of really heavy precipitation. Cold air you could see was coming down from Canada at the same time, so there's a very nice baroclinic zone. Right along that baroclinic zone, we had extreme icing, up to an inch or more than an inch of ice in some of these places, to our north and then in Michigan as well. And if we just scroll forward a little bit, you'll see this band of icing and wintry mix sort of just stays there for a couple days, producing that really intense accumulations. And then there was a nice snowstorm in North Dakota and Minnesota at the same time that was happening. And then we had blow up of convection, you can see. This was the beginnings of a first severe weather outbreak that happened over the southeast or in the southern United States here. We had some storms maybe from it, but not too significant. It was still wintry mix, and then here's the really heavy convection at this time. If we go to the end of this day, so just after midnight UTC time, at 0Z, yeah, that's perfect. This was the first of 2 main severe weather outbreaks we've had over like 3-day period. So Indiana, Michigan, all the way down to Arkansas have been sort of the hot spot for severe weather recently. This was the first one. There were hail, tornadoes in this region. This was not the main severe weather outbreak that we've probably heard about, though. This only had a couple of tornadoes, and I say only a couple of tornadoes, but that's still pretty cool, I would say, to have this sort of set up and storms happening. This moves past quickly. If we could go to the end of the day on March 31st, you'll see this line of storms moves into the southeast, producing severe weather over the southeast. And look what's right behind it. Another trough, another system. This is going to be the main weather maker that we've seen, that there was pretty bad tornadoes over Kentucky into Arkansas, Tennessee, and Missouri. Again, they've had like 3 or 4 of these this month alone, and it looks like there might be another one today in Arkansas. So this area of the United States is reeling from storms, and I can touch on why briefly, but it's more important to just focus on that it's happened and it's continuing to happen over and over here. So you'll see here's a trough, general clouds and precipitation moving in from the west. And if we go to, yeah, this is perfect.
Gap in there. I had a machine that was down until somebody emailed me and told me it's done.
Oh, that's really fun. If we could go just towards after 0 UTC on the 3rd of April, you'll see. So here's the big blow up in convection. You can see some of these cloud tops are making undoubtedly into the stratosphere. They're so cold they're turning up as white. And you can see if you look on this map, the only other place you see that is in the tropics. And so that's how intense and how high these storms are relative to the other convection going on. This, at the same time, was producing significant tornadoes, especially ones in Arkansas and Tennessee. We'll take a look at one of them specifically here. But this was the high risk, the really strong storms. All of these storms, it's sort of forgotten about, but they bring precipitation. And one of the things, if you've seen the headlines, there's a lot of flooding going on. We had one severe weather outbreak. This was the second one. We'll see if we keep going in this loop here. You'll see there's still convection and precipitation development right on its heels. And so some of these places have had double-digit rainfall already, and it looks like they might get another 10 inches of rain on top of it, along with the severe weather threat. So just probably terrible week to live in this region. I think Nashville, Tennessee has been under a tornado warning like 2 or 3 times in a row overnight. And so it's not just hitting rural areas, some of these are hitting metropolitan areas. And right here you can see on the heels, here's the next wave of precipitation and storms about to make its way in the same place here. So that's the week recap. And we might see, we're sort of seeing the high clouds from ongoing precipitation there. Could we go to Google? And we'll take a look at one of the tornadoes that happened because it was, I think, a very cool video of tornado. Can we search Lake City, Arkansas, please? Tornado. And then if we go to videos, and which one was it? Oh, this one. Yeah, let's see. So this was one of the tornadoes that was produced. A long track tornado. This did not just hit one area. It moved over, quite a bit of land in northeast Arkansas. Specifically, I want to focus on, after about a minute of this video, there's a very cool capturing of this. And so I'll just let it play here. You can see how big it is, too. This is pretty significant. It was very moist, very warm, so the cloud tops you can see are not that high. A lot of power flashes from it hitting buildings and stuff. Once it gets to a minute here. Let's see. So it sort of disappears in the background, and then it switches to another video, if this is the right one. think it is. Yeah, here we go. So this is a look at somebody in their storm shelter, and look at this tornado. You can see, I had to Google this morning. These are what's known as horizontal vortices. That's not what I Googled. What I Googled is what the heck makes them in a tornado specifically. Could we go back to 59 seconds in this? Because it's pretty interesting what happens. So a tornado is a region of lower pressure. Specifically in the environment it's forming, it's going to be extremely low pressure, especially inside the tornado. That causes rapid cooling and condensation. That's why you see a funnel when there's a tornado. Otherwise you just see wind and debris. But so there's rapid condensation, you can see the water molecules condensing. What can also happen is if you have a really strong tornado, outside of the tornado, you have condensation going on, away from the vortex. This is why we can see these horizontal vortices, because there's really strong wind going around the tornado, obviously. Surface friction is going to create wind shear, and then the tornado can ingest that wind shear, that rotation, and if it condenses, you can see it being ingested in the tornado. So if we play this, you'll see this is spinning horizontally and gets sucked into the tornado. And so it's unclear. I couldn't really tell if this is, does it strengthen the tornado? Is it just, it always happens and we are just seeing it from this specific tornado? Because you could assume if there's a tornado going on, you're going to have that pretty strong horizontal shear around it, and the vortices are going to be ingested into it. But one study suggested this only happens in really strong tornadoes, but it wasn't conclusive about that. So, and here's a look at it from a distance. Very strong, very significant tornado. And this is one of, a dozen that happened specifically in that region here.
Look at the closed captions.
Yeah, don't look at the closed captions. The language might not be that appropriate.
So Patrick,
Yeah.
are you suggesting that it's the frictional generation of vorticity? I mean,
Yes.
an alternate explanation, I'm not sure if it's viable, would be baroclinic generation, because you must have a cold outflow because of, in the downdraft, and that can lead to density gradients and vorticity generation that way.
Definitely. The preferred region is in that rain-cooled downdraft. So that might be playing a role. From the one single paper I read on this, it was the surface friction, but definitely could be baroclinic in nature as well. Might be both at the same time too. Yeah. Okay, let's go into the current weather. Could we go to the 500 super? Oh wait, let's go to the satellite actually, please, first. So take a look at what's currently going on. Here's the next round of severe weather and storms. You can see all this moisture. If you track this back, there's an extremely broad region of high pressure and anticyclone. All of these clouds and moisture are being brought straight up into portions of the southeast, and then the place that has continuously gotten these storms and rain and everything. And you can see that beginning to produce clouds and rain and storms over the southeast. Specifically, Missouri into Arkansas, Oklahoma, Texas. This is eventually going to move towards the east, but right now that seems to be the focus where the clouds are the heaviest. There's a lot of just spotty convection. All of this pixely gray is probably just cumulus clouds in the really nice moisture and very warm temperatures. Over us, it's generally cloudy. Seems like it's high clouds based on the kind of wispiness of the clouds. They're not as white and thick looking, I guess. There's probably a better word for that, but they look very wispy over us right now. You can see the snow cover in Canada. Those aren't moving, so that's snow cover. And then spotty storms and some snow cover over the west here. But this is the main focus of what I'm going to focus on is why are we getting so many storms, specifically today over Arkansas seems to be the bullseye here. One component is we have really nice, warm, moist flow from the Gulf interacting with, it looks like some sort of boundary moving towards the east here. Could we go to 500, please? The 500 hectopascal map. We'll take a look at the troughs ridge pattern first, because that's always a good indication. What we can see here This is valid for this morning. We have a very deep trough. It extends, maybe there's an extension all the way up from Canada, but there's one shortwave and a second shortwave that extends all the way down towards the southern tip of Baja California. So all of the western portion of the United States and into Mexico are under this trough axis. That means there's general divergence out ahead of it. Not too intense. We don't really see a decent ridge where you get that strong ageostrophic divergence, but there is general ascent downstream of this trough here. You can see from the wind barbs too, even at 500, there's sort of this flow from the Gulf. So even in the upper levels, there's flow up from the south and from the Gulf of Mexico where you're getting that warm, moist air here. And it's pretty uniform. There's not too much of a temperature gradient, but it's generally warmer down towards the southeast, a little colder towards our region and into the plains, so there is some baroclinicity where you're getting this general ascent. That's what I can see here from this map here. Can we go to 850, please? So look a little closer to the surface. We see that general ascent in the upper levels, and bingo, here you see really strong, warm, moist flow, straight southerly flow right off the Gulf of Mexico up into where there is a baroclinic zone, situated Illinois into Oklahoma and Texas. And it's very warm, 18 degrees at 850, very low dew point depressions here. So this is really warm, moist air. There is a baroclinic zone. We have general ascent from the 500 millibar trough that's situated off the west coast. This is why you're focusing storms in this region specifically. And we can take a look at the surface too in a second here, see if there's anything else that might be helping lift specifically over Arkansas, Texas, because there's, from this just setup, there should be general storms over much of the southeast, it looks like. And there is sort of this diffluence pattern where you have this really nice southerly flow, and it spreads out in a diffluence over this temperature gradient. So that might be a region where we focus that the ascent, the condensation, the moisture generation, precipitation, everything like that. Mainly due to this anticyclone sitting just off the coast of the southeast, bringing that warm, moist air up from the Gulf of Mexico, it looks like.
So
we, yeah.
I was gonna say, maybe this is, I don't want to cut into what you might be about to say, but you set everything up to basically talk about some at least frontogenesis,
Yes.
and it's clear that
Yes.
the baroclinicity, at least at this level, isn't the most intense, but there is some.
Correct.
But that diffluence that you noted is really significant. And
Yeah.
so that coupled with the isotropes, it's going to probably be frontogenetic.
Absolutely, yeah, absolutely. There is still pretty good, I mean, this is, maybe the temperature lines and the isotherms are not too representative, but 6 in central Illinois into 11, southwest Missouri 14. So there is decent baroclinicity right where we see that diffluence. And the winds quickly slow down too. So there is really probably pretty significant frontogenesis ongoing in that region as well, yeah.
And I'm glad you noted that. Yeah, there is definitely baroclinicity there.
Yeah.
And maybe the reason it doesn't look as impressive is we've lost some radio sons in the last week or two.
Great
So
point.
one from St. Louis, Green Bay,
Yeah.
and other places in the Midwest. So you really can't
That is a great point.
trace that out.
Yeah,
Nashville.
unfortunately. Yeah, Nashville.
Oh, that's
Yeah.
gone too.
Mm-hmm.
It's
There's
not
no
showing up
observation here. And conveniently, where are the storms going? Right here. So, we'll continue to see the effects of this, but this is particularly bad if you're not launching radiosondes, sampling the environment over where we are seeing the very strong storms.
They're also not going out and doing damage surveys because they don't have
But
enough
that's
people.
right. Yeah.
And did I hear, was it Paducah, that they couldn't afford to fix the plumbing, so they had a porta potty out in the parking lot, and they're like dealing with tornado warnings and having to go outside and use the bathroom?
I hope not, because there's 6 inches of water on the ground now. I don't know. Fun times we live in right now, specifically for the weather community. Can we go to the surface, please? And then this will be the last thing I show here. So, okay, there definitely is some sort of baroclinic gradient here where we have 80s and 70s into 50s in portions of Ohio, Kentucky, Indiana, all the way down to Oklahoma. So very strong baroclinicities at the surface, and you can see it's producing thunderstorms over southern Indiana, Illinois, very heavy rain over southern Illinois, and this extends all the way down into Oklahoma. So that is definitely matches up with that general ascent, the baroclinicity at 850 specifically, and then at the surface as well. And you can see the nice warm moist flow. Dew point 76 over 83 in New Orleans, which that is just, I do not like heat or moisture, so that would be terrible for me specifically, but it's still April, and these are, you know, more summer-like conditions we're seeing. But then if you go just slightly north, you're in the 50s and 40s and it's raining, so tale of two seasons. We have record warmth over the southeast, and it's a normal spring day over the mid-portion of mid-Atlantic and then into the central plains as well. It actually looks like also, where did I just see that? There might be a cyclone also responsible for a portion of the ascent over Texas, and that might make its way into the region of interest where we're seeing those really strong storms, nice flooding, the whole shebang going on here. I think that's all I want to point out. And then it also, on the backside of all this, it's snowing still in the Dakotas and Nebraska and Colorado. So there still is winter over the United States, it's just well off to the north and west here. That is all I have. Does anybody want to see anything else? Okay, I'll pass the metaphorical.
Okay, let's keep that up, Pete. Yeah, thanks, Patrick. So it's really, yeah, this is interesting. I guess the question that still lingers for me, and I'm not certain, I haven't looked at it carefully, those of you taking 453 might want to chime in on that, and Patrick, certainly your analysis and diagnosis of this might be helpful. But you looked at the conditions for that severe weather there. And obviously, the boundary layer is sufficiently moist. We have a deep trough to the west, so there's a broad area of ascent. Maybe that weak cyclonic circulation that exists over northeast Texas might play a role later as it sort of ripples along the baroclinic zone. But why the significant focus over parts of sort of Arkansas, western Tennessee, maybe southern Illinois, southeast Missouri later today? Because there's not a potent upper trough that's going to sweep through the area.
Right.
So is it just the shear in the vicinity of that baroclinic zone? This is just a question. I don't know the answer to this, so I sort of
That
invite
seems reasonable.
any speculation on that. The other thing to point out on this, which will have an influence on our weather later this weekend and to early next week, are these colder temperatures that we see well to our northwest. We saw that there was a fairly sharp upper trough located in southern Canada, in Alberta, Saskatchewan, Manitoba. And so this area, this broad area there, we saw an upper trough. That's going to be swinging through the area later this weekend, and that's going to certainly get us a little bit cooler as we move into early next week. So we'll be watching that in the forecast. But one of the big things that's happening, we'll take a look at the national radar, but Pete, I don't know if that loop still exists. You had a accumulated precipitation from whenever the event, the precipitation started at these radar sites in the southeastern United States. Let's take a quick look at that. So this is the accumulated rainfall. It's sort of tough to figure out. It's whenever the radar was turned on to begin for the storm beginning, but you can see amounts in parts of this is in Kentucky, central Kentucky, that are already in excess of about 12 inches. And we're going to see that the potential for flooding broadly in this area, sort of lower Mississippi Valley into the Ohio Valley, is the threat for flooding is going to be significant for the next at least 24 hours or so. And that, coupled with south of this area of heavy rainfall, the potential for severe weather is going to make the weather over the next 24 to 48 hours pretty interesting. So let's step back from this. Let's first take a look at SPC's page, just to see where the significant storm threat is later. I think it may already be up there in the tab. Yeah, and actually, let me go back to current, I guess. hopefully these websites are not going to be affected by the impending shutdown of lots of NOAA websites, more on the research side of things, in the next, by midnight tonight. So we'll see what remains tomorrow. But a moderate to enhanced risk of severe weather extends from northeast Texas all the way through the Blue Hill of Missouri. And you can see this area is an area that's, and we saw on the satellite, is still relatively clear. Most of the clouds are just north of this where we're seeing the heavy rainfall that's occurring. Early this morning, St. Louis had a thunderstorm with heavy rain, and now visibility is what, 4 miles or so in St. Louis, but the heavy rain has now moved into parts of southern Illinois, and the rain that we saw is sort of ending right now, the accumulated rainfall that we saw in parts of Kentucky. We'll just see how much of that begins to pick back up later today. For our area, still dry, but we have those cirrus clouds over us, and we're going to talk a little bit today about just how close that rainfall is going to be, what are some of the mechanisms, and look at it maybe from a slightly different perspective than we typically do. We'll look at it in an isentropic context in just a few moments. Let's look at the radar, even though we have some imagery there. Let's look at the current radar. So in our radar reflectivity, again, just sort of showery, convective, small scale convective cells over Mississippi this morning. And again, that band of heavy rain is really well delineated here in the radar reflectivity. Some convection near the Dallas-Fort Worth area with some storms. I think at least yesterday they were anticipating early on some of the models that some fairly intense convection that was forecast. I think UW-AOS yesterday had that. I don't think it actually emerged fully by this time period, but still some showers and thunderstorms in Dallas. And then we go further to the west, you see some of the snowfall in the Dakotas. Some of this might be rain or snow out into Mexico at this particular time. So nice setup, a lot of rainfall. One of the questions is, will we get rainfall? If so, how much and when? And what happens further into the future? So let's first look at let's go to tropical tidbits. Please. I don't know if that's up there. Actually, if you bring that up, and also, I don't think they have this. Let's go to forecast models first of all. You might be able to see it here. And then we have the GFSs loaded up. Look at their so-called upper dynamics page, and do they have the 2 PVU pressure and wind? Okay, so this is a slightly different perspective. Instead of plotting airtail potential vorticity on isentropic surfaces, right, you have to figure out where's the isentropic surface that's of most interest to you. People often plot the potential temperature or pressure along a surface of constant potential vorticity. The 2 PVU surface really is the surface where you'll find typically where the jet is at any given isentropic level, particularly in the middle and upper troposphere into the lower stratosphere. So this is a different perspective than the traditional 500 millibar analyses that you are accustomed to looking at. On this, the higher pressures indicate where the tropopause is lower. Okay, so we can see the tropopause dipping down to, the dynamical tropopause dipping down to about 550 hectopascals or so in this region. And then the base of this broader upper trough, it's not as deep, maybe around 420 or so hectopascal. This broad area where we see the pressures are much lower really indicates an elevated tropopause, which is going to be associated with that big broad ridge that extends over the eastern part of the United States into the subtropical western Atlantic. And so we know at upper levels we have this broad ridge, and at low levels we saw that the flow becomes more easterly, and we have that transport from the Caribbean into the Gulf into the southeastern part of the United States. So, as we were talking just a few moments ago when I began, if you look upstream, there's not much in the way of any significant weather feature in the middle or upper troposphere that we might anticipate is going to trigger some of that intense convection later today. So it must be something, at least from my perspective, the trigger must be something that's in the lower troposphere that might have a amplifying effect in terms of increasing the low level shear, things of that sort, but it's not like you're going to see a deep, cold upper trough propagating over this region. If we were to step forward in this is a 6-hour forecast, just to see how the dynamical tropopause evolves. This is valid by later on tonight. Again, these cooler areas here are where the tropopause is depressed. I mean, there is a little bit of cooling here, but that could also be due to some of the convection that's occurring in that area. The speckled nature of this tropopause, you think of the tropopause as a sort of fixed lid. It's going to be modeled here because how they construct this map is evaluate every grid point where is the PV to PVU. So folds and things like that aren't going to be well represented here, but where you see strong gradients of pressure along the dam, tropopause indicates where you might expect to see jets. That's where a near fold is occurring based on how this is analyzed. So sharp upper trough here, that's goes down to 500 millibars, propagating broadly to the southeast, and we have this sort of cutoff that's formed in the PV field or in the pressure field along the dam of the tropopause, which is still hanging down to the west. Let's step forward a couple more clicks. Okay, so now we're through Saturday, by Saturday evening. And for us, we're still under broadly the influence of this ridge. This trough is moving southward. For those of you that have taken 452, you know that underneath where the tropopause is depressed in terms of its height, you expect the isotropes to bow up, so it's colder beneath this trough, and we'll see that that's where some of the cold air that's going to seep into our area later in the day on Sunday as this trough approaches and then eventually gets by us. So let's step forward a few more steps. The trough hasn't quite reached us. In fact, it flattens out. Tropopause is a little bit lower still back to its west. This is Sunday morning. And then there's one more piece that comes by us. If we step forward, keep slipping forward. This is actually, I guess, going to be the piece that's the key one. That first one was kind of a fake faint. Looks like it was going to head toward us, but no, this is the one that comes through on by Monday morning. So if we step back forward, just step back again to see where this comes from. Yeah, it's actually out of the picture initially. And that first one that was headed southeastward, my mistake, is not the one that's going to give us the cooler weather. So we have it passing by to our north. There could be precip to the north over the weekend, but then this is the one that's sort of, this comes into the map, is the one that could give us maybe some inclement weather on Monday in the form of snow showers, particularly as the winds turn to the northeast at the surface as this passes by. So we'll see that in the forecast. Okay, let's go back to this afternoon. So sometime this afternoon, we'll go back 6 or say 12 hours of the forecast. Let's look at precip moisture, and we'll look at the surface precipitation and sea level pressure. So this is the forecast for 18Z, so roughly right about now. Okay, you can see the broad area precipitation kind of matches up well. This is accumulated precipitation over the last, I believe, 6 hours or so. And so you can see it matches up pretty well with where we saw the radar indicator precipitation. Some of the snow in the Dakotas shows up pretty well, and the precipitation in parts of eastern New Mexico as well. What I want to do is, first of all, let's do a cross-section through this band of precipitation, and we'll keep it, actually, if you could step forward just one time frame, I just want to make sure that this is roughly the same location. Okay, it's moving. Let's go back to 18Z. It will be somewhat perpendicular to the isotope. So let's say from near International Falls down to my finger, I'm not sure where that is. It's going to be north of Savannah, south of Charleston.
This is more from like lacrosse.
Okay. So what we can see here, yeah, that's not going to do it well. Sorry, that was my mistake. Let's go back. I should have saved the 60 images. What would be this?
We can change runs, right?
No, let's do this. Let's not go in this direction. Let's go more. Let's perfectly bad like that. Okay, and we can also change time. All right, keep that. Roughly. Control and then.
I did.
Oh, you did. Okay. It's a bit better. So these greenish contours are theta E. The pink area is our frontogenesis. See this frontogenesis exists. There's some at the surface. You can see sort of the nose of the theta E front, if you will, here. It's steeper in this location, and the shaded areas are areas of ascent, minus omega. Gray is going to be descent. So a nice frontogenical circulation shows up here in the lower to mid troposphere. And so this is in part one of the reasons we're going to be seeing the significant precipitation along this baroclinic zone, as was indicated by Patrick, that nice confluence along the surface baroclinicity and also mid-level baroclinicity, which, again, this is partly the strong gradient you see here at this level is obviously due to both water vapor and temperature differences, since we're looking at theta E here, not theta by itself. Okay, let's just click on this for a second and go to the just PD for a moment and submit. Okay, you can see here the theta contours are much less steep here, owing to the fact that we're not looking at just moisture, in addition to moisture differences, just temperature differences. The shallower features that you see in theta in the cross section indicate that the surface, the horizontal temperature gradients are going to be weaker in the mid-troposphere. There's a little bit more steepness closer to the surface, which we saw with the surface front. But again, it's in that in the lower troposphere where we see a fairly strong thermal gradient. I mean, there is a modest one that exists all the way through the depth of the troposphere. Dynamical tropopause is kind of, if you look at the 2 PVU surface, as you go from blue to the orange and yellow colors, shows up pretty well here. And that's what we have going on at this point. Let's step ahead just 12 hours in this time-wise. You can just go quick here. You can see that front persist. We can see, if we go back from convection vorticity to the initial one that we had, the frontogenesis. Okay. And down here, the surface frontogenesis is much stronger. Again, strong ascent. This is probably a convective plume that you see here, with convection. And if we go back to here, and we're going to look at the in-plane wind. So this is the plane along the cross-section. A couple things that show up. Okay, so here, negative values are going to be from B toward A. Okay, so this is that surface lower tropospheric inflow that we saw earlier. Look at the isotropes here. So we have air that's riding effectively, as long as it's not saturated, is riding in along these surface isotropes up into this region. Again, I looked at a cross-section earlier. I should have just saved the one that I had there, but you can see the component of wind in this cross-section, effectively normal to where this front is located. You have this sort of low-level jet that sort of terminates here. So mass continuity would imply we're going to have ascent here as the flow begins to slow down. Again, that's assuming in the other dimension we're not seeing much change in the flow through the cross-section. But this is in part evidence of the front that we see here in the frontogenesis. But what I think is going to be interesting to look at is that we have this broad southeasterly flow. It's moving, southeasterly flow, moving toward the northwest. Eventually, when it reaches the surface baroclinic zone, or this baroclinic zone, it's gradually increasing in altitude. Then eventually it reaches saturation, and it doesn't stay on these isentropic surfaces. It actually begins to flow more across isentropic surfaces because theta is no longer being conserved. So let's look at, we'll close this out, and let's look at some maps from this time and the earlier time. Go to upper dynamics, and we'll first look at the 290 Kelvin surface, which is unfortunately much of it below ground, where you get the isotropes sort of outcropping as you get close to the surface. Let's go to 300, I think will be a little bit better this time. Okay, so this is an isentropic analysis forecast, if you will, at this particular point. Curious that it's below ground here, but above ground there, but I'm not going to even think about that right now. You can see here pressure, the isobars along this isentropic surface. So you can see the surface slopes as you go from south to north. It slopes upward, right? Higher values of pressure in this part of the map, toward lower values right here. The shading is relative humidity, green areas being more closer to saturation, and drier areas showing up here is gray. And you can see the component of wind along this isentropic surface is directed from higher pressures toward lower pressures, right? So there's nothing like geostrophic balance that we see here. You need another variable to be plotted here if you want to try to look at the geostrophic one. That's the Montgomery string function we want to plot. But what we see here is that these air parcels, if this isentropic surface were perfectly stationary, or riding up along the isentropic surfaces, if it's sloped, the flow, and it's preserving theta, these air parcels will just travel right up along the theta surface. So you could also sort of look at pressure advection or minus pressure advection along the surface to diagnose the vertical motion here. But the one thing you have to do to use this tool as an analysis for vertical motion is you have to know what's the relative motion of the isentropic surface itself. So you can imagine, here's an air parcel at a given time at a given level. If the isentropic surface is moving at the same speed as the air parcel, it's not going to be able to ascend. But if the air parcel is moving relative to the isentropic surface, moving faster, let's say, to the north, the parcel is going to ascend. So there has to be corrections that are done to figure out what the actual vertical motion is here. But if we were to plot vertical motion, or at least the evidence for it from the precipitation, this is this band right here where we saw it occurring. Further to the north, in this dry air to the north, we can see broadly subsidence, again, if this isentropic surface is not moving relative to these air parcels, so you have the subsidence here. And this broad confluence gives you sort of a sharp cutoff to the precipitation on the northern side of that. Ahead of that upper trough that we saw earlier, you can see there is some modest cross-isentropic flow, but you have to, again, include the effects of the motion of the isentropic surface itself. This is sometimes a useful tool to look at for diagnosing vertical motion. If we go ahead one more time step in this, we can see, the other thing we're going to do, actually go back for a second, I'll just show another neat thing. We were talking about the high clouds that we saw over us earlier. Let's do a sounding right about Madison. And so you can see in this plot, again, we're still in the relatively dry air, so we have this moist air that's above us. It's basically saturated with respect to water and ice above us, and we have this dry layer over us. So that's why we're not getting precipitation. But if we were to go further to the south and say central Illinois, you can see a little bit it's still not quite saturated there, but you can see here that a deeper moist layer, and we know that it was precipitating when we get to southern Illinois. So let's go just a little bit further to the south. So again, this notion of this broad area of ascent that's occurring, it never works when you want it to. But you can see that it's, again, all the way down to the surface it's saturated. There's some areas here where there's some dry layers. Again, which isentropic surface you want to look at. There's obviously a gradient in the vertical of water vapor content, or obviously relative humidity, because we have these areas that it's not quite saturated. But it's moist enough for them to be getting precipitation, at least in reality, right now. Okay, let's close this out. And we'll go to pivotal, just a more traditional view, at least for me. So, we know in the forecast, I should have kept that up because there's nothing I want to show you on that, but we'll go back. Let's keep going. All right. Now we'll advance the time and just look at Madison. This is valid tonight.
So you see in 7 o'clock.
Right, so if we just click on there and do the sounding, remember it was dry in the lower troposphere, still dry. Let's go ahead time-wise. Let's watch the column voice out. There we go. So we're going to be that moisture being advected toward the north, eventually saturating. So these air parcels are no longer following the theta surface. They're actually going above that theta surface, so going to higher values of theta E, due to late heat release. So we'll get close to saturated basically. So there's a slight chance for some precipitation this evening, as long as the lift is significant. But we're certainly going to have lower clouds by later this afternoon and evening into tonight. Now we'll cut this off and go to pivotal. And we'll go to surface map. Preset. And not North America, we'll look at just national and then US. All right. And we'll go to, say, 18 hours in forecast. So here's that light rain that we're expected to have had by this time, or by 12 hours from now, 18 hours from now. There's the precipitation. Again, heavy precipitation, convective precipitation is down to our south and east along that boundary. And the upper trough that we saw in the forecast, these elements of it, you can see the cold advection, but largely that cold advection kind of halts as you get into central Iowa. Step ahead to tomorrow morning, 24 hours. Weak cyclone is formed along that baroclinic zone and continues to the northeast, but another round of heavy precipitation down in the southeastern United States, not getting much of a break at all. Cold advection around us with the northerly wind shifting to the northwest, the northeast tomorrow. And let's just jump ahead to Sunday. Tomorrow is going to be largely dry. Sunday, dry again. We're between this broad anticyclone to our north and some lower pressures to the south, but we're in this whole region, so light winds on Sunday. And you can see the beginnings of another surge of cold air. You can see the cold advection sort of strengthening back here in central Canada. Let's go ahead to Monday morning. You can see that cold air has moved rapidly to the south, strong cold advection over us, and that's when those thicknesses begin to tumble. Winds off Lake Michigan, so there could be an area of some frozen precipitation in parts of the eastern part of our state on Monday. And temperatures pretty much during the day, if we were to look at surface forecast temperature, we look at that, upper 20s, low 30s at 12Z, and then we just stay kind of chilly throughout the rest of the day. So that's what, 33 or so. And if we go ahead 78 hours, still not much change. So a chilly day as we go into Monday, but dry, at least, with maybe snow confined to the eastern part of our, southeastern part of our state. Let's go back to the surface map, please. And I want to just, okay, so large broad anticyclone, cold advection over us. We're cooling off. The rain has fortunately ended in the southeastern part of the United States. And I want to just jump through this quickly. Go to 96 hours, please. So Tuesday morning. That cold air continues to head eastward, and we have a nice, at least temporary warm-up beginning to set up for Wednesday. So 120 hours. But with any warmth and this air coming off the Mexican plateau, those areas, it's going to be a long time as it's moving northward. Again, you can imagine these as later being isotropes. That air fairly dry. It's going to take a while before it saturates, but eventually it will, at least in the forecast it is, and that produces that precipitation over parts of our state. Let's go ahead to 144 hours Thursday. The cyclone forms over us. We could go through this time-wise, but I want to just watch that. But there's a little bit of precipitation over us Thursday. We go to Friday. This is going to clear out. And back to hopefully another chance of trying to warm up. The very last thing I want to do, I always like going way out in time, but if we go to 348 hours, I think this is it. And go back, let's go to 336. I'm going to get the best time on this. All right, pretty impressive cyclone. As I was sitting here looking at my iPad as we were just beginning, I noticed this in the forecast. It's like, wow, I don't remember seeing that earlier this morning when I was kind of looking ahead to last night's run at 6E. Let's just look at the 6E forecast. Valid at the same time. Nothing. So that'll be an interesting thing to watch over time. Fortunately, it's on one of our weather watches, 2 weather watches from now. We'll see what happens, but I'm not going to be tracking it like I did for the for weather our spring break weather watch. For the first day before spring break weather watching. But that's just interesting. That forecast fracture, that's something that, again, always interests me, is what's happened well upstream, probably something over Asia or the West Pacific, that's triggered that difference in the forecast. And if you go back and look at earlier runs, I think you're not going to see anything like it. Is this the same disturbance? I'm not certain. But even further back, again, just a lot of sort of noise in the forecast. So that's an interesting aspect of it. We could, we said that was what, 336 we're looking at, or was it 342? Where it showed up at the current time. Let's go to the 12Z. Since I think it's within the range of our of ECWF from 0Z last night, we can change that just to see, where the AIFS could work. And tell you when. We don't have to change the time because it's a different run. There is something there, maybe that system that we saw earlier in the 6Z run, or no, the 0Z run from last night matches up with this from the GFS. But there's potential several Fridays from now, a couple Fridays from now, for maybe a cyclone somewhere of interesting intensity over the western or central U.S. So we'll just watch that over time. In any case, for the weekend, today, it's cloudy, maybe some light rain or showers this evening. That clears out. Tomorrow should be a nice day for pie. And then we move into Sunday, nice light winds early, and then the winds are freshening from the northwest. Colder on Monday morning with some clouds, particularly to our east, with maybe a chance for a little bit of light snow, but probably not much in terms of accumulation. If we look at the very last thing, go to forecast, and then we'll scroll across the top. NWS, WPC forecast. Has been updated. If you look at the winter storm severity index, it does have an area over us of some potential for winter weather that could have some impacts, but these are relatively low impacts at day 3. So that's that second upper trough that goes by on Monday morning as we get that freshening cold advection coming in. So, and then the rest of next week looks mild-ish, but we're going to get back into some rain by Wednesday, and then by the end of the week, next week, we should be back to slightly warmer temperatures and hopefully dry weather. So thank you, thanks Patrick, and thanks Pete. Have a wonderful weekend.